So hey, classifying triangles, section 4.1. We're starting into chapter 4 now. Chapter 4 is all about special triangle properties. Okay. Now these first two sections, today and tomorrow, should be a lot of review from what you would have seen in 7th grade math, 8th grade math, a little bit of algebra, not so much algebra, more 7th and 8th grade math here. Okay. So hopefully they're a review for you. Hopefully you can remember these different things. But as we continue to progress into this, we'll learn a lot more about triangles and triangles congruence. Troy, I know you said the other day on the map test, right? You got something that said SSS and SAS, right? That's this whole chapter right here. So we're going to start diving into that here.
So much of that. That would have helped if we were one chapter.
One more chapter. Almost there. But classifying triangles here. Vocabulary here. These are the different types of triangle classifications. Okay, again, all these should hopefully look familiar for you. Acute triangle is a triangle with 3 acute angles. Now, acute meaning less than 90 degrees. So I have kind of that's not a good one. There we go. So an acute triangle is a triangle with 3 acute angles. So I could have the angles, 50, 60, and 70. Those would be acceptable angles for the triangle. Okay, so all 3 of the angles are acute. They are less than 90 degrees. Equiangular triangle is a triangle with 3 congruent angles. Okay, so my triangle there, my angles would all be denoted as congruent as such. And Camden, I think you said it. What would the angle measure then be of all those?
60, 66.
60. So that'd be a 60, a 60, and a 60. It's always 60, 60, 60. Okay, now something that you should recall, hopefully from 7th or 8th grade math, is that triangles add up to 180. The angles in the triangles add up to 180. Okay, well, that is something we're actually going to review tomorrow. Okay. But yeah, equiangular triangle, all the angles are 60 degrees. A right triangle is a triangle with exactly one right angle. So if I look here, something like that is a right triangle, and it's usually denoted as such with the right angle symbol in there. So anything with a right angle, so let's go 90, 60, 30, which is a special right triangle we'll talk about in another chapter. But 90, 60, 30, so anything that has one right angle, a right triangle. Is it possible to have 2 right angles in a triangle? No. Why is it not? It would not work because it has to have 3 angles. 90 plus 90 is 180 already. It doesn't work. Then the angle doesn't exist technically. Obtuse triangle is a triangle with 1 obtuse angle. So anything larger than 90 degrees. Okay, there's kind of an obtuse triangle. And again, anything that's over 90, let's go 100, 50, and 30. I'll take a little bit. There it is. But again, obtuse triangle, anything with an angle larger than 90 degrees. 91 degrees, and it's obtuse. 90.5 degrees, that's obtuse. Equilateral triangle. Now, here's the thing about these. An equilateral triangle and an equiangular triangle are the same thing. They'll always be classified the same. If it's equilateral, it's equiangular. If it's equiangular, it will be equilateral. So note, those two are always tied together. Not really. But that's a triangle with 3 congruent sides. So now we're talking about side lengths here. So that's 3 congruent sides. So that could have, lengths of 3, 3, and 3. All of them would have the same length. And again, if it's equilateral, it's equiangular, so all the angles would all be 60 degrees as well. Isosceles triangle. This is kind of one of those important ones that we always seem to forget about. Isosceles triangle is a triangle with 2 congruent sides. Okay, 2 congruent sides. So look at something like that. It is marked as such, so 2 congruent sides. And I could have angles of 4, 4, and 5. And that's isosceles triangle because 2 of them are the same. So 4, 4, 5, 10, 10, 11, 9, 9, 13. Okay, anything that has 2 sides the same, that they're marked the same, they are congruent. And then the last one here is a scalene triangle. It's a triangle with no congruent sides. So something like that, they will have no tick marks. On a scalene triangle, there'd be no tick marks denoting that they would be congruent to each other. Okay, and that would be like, let's go with 4, 5, and 7. 4, 5, and 7. Okay. That would be a good example of a scalene triangle. What?
40, 50, and 70.
For angles? Yeah. Oh, on a scalene triangle, all the angles would be different as well. Is that what you're asking about? Yes, that'd be good. Yep.
That wouldn't work out. That's not, that'll add up to enough.
That one won't work out.
40, 50,
It'd be 40, 50, and 90. Which would work?
then it'd be a right triangle.
Then it would be right triangle. Let's see here. You can classify triangles by their angle measures. So again, what we talked about here. Here are the same examples we just got done talking about. There's the acute, right, and obtuse triangle. And up there is the equiangular triangle. Notice again, like we said, all the angles are 60 degrees. Okay. We will have some of these later on where it gives you multiple triangles within one triangle. Okay. The key to that is making sure you can find the missing angles. So they kind of show you over here. How do you find that missing angle? Well, always remember a line is how many degrees, Jessica? A line is how many degrees? 180 degrees. Okay, so if I ever need to find a missing angle and I have one of the angles, well, I just subtract from 180. Okay, and you can always find missing angles that way. Alright, so let's look at these here. We're going to classify the triangles by their angle types. So number one, I have a triangle that is 60, 60, and 60. What type of triangle might that be, Bryce? Well, I agree, but there is actually a better name than that. Equiangular. Nice job. That would be equiangular. Now, Mott, you are correct because equiangular is equilateral, but because we're looking just for the angle type, we would say equiangular. Does that make sense? Now, you would be correct. Equiangular would be an equilateral, but looking for that angle type. Number two, I have a 30, a 60, and a 90. What do you say, Gabe? I do agree. However, we're talking about the angle types again. So that would be a... What is it? Do you have it? That would be a right triangle. Nice job. Now, technically, that would be a right scalene triangle, as you said. That's fine. But no, we're looking just for the angle types right now, so that is a right triangle. What about number three? What do you say for number three, Keegan?
Obtuse.
That is obtuse. It has one obtuse angle, so that is an obtuse triangle. Very good. And number four here, 45, 45, 90. Oh, what do you say there, Jersey? That is a right triangle. Yeah, that 90 right there denotes the right triangle. Again, you're just looking for specific angle types, and you can name the triangles. All right, next one here. There are three triangles here. Take a couple seconds and classify these three triangles. All right, number five. I'm looking at triangle DFG. So I'm looking at the big triangle here. What type of triangle is that big one, Kay?
Right.
How do you know it's a right triangle? Right there? Yeah, that little square denotes that's a right angle. So the big one is a right triangle. Nice job. Angle DEG now. Well, we're looking here. I have this triangle. I know two of the angles there. What's that third angle?
No.
Oh.
Go back to the first one. That's not the right angle.
Yeah,
it is. What
D,
in the middle? The
F,
is in the corner.
G.
It's a triangle.
That's a triangle?
Yeah, no, but it
Next
would
line,
that
Martina.
way, wouldn't it? Because F's in the middle.
You're saying DGF?
It's just they're
It's the
F's in
same
middle
thing
of
on the triangle there. So it's the same triangle.
How's it a triangle? It's the
That is triangle DFG. That is also triangle F or GFD. I could also say that's triangle FGD.
yeah, but if the F was in the
DG,
middle,
DFG.
That's-
She's thinking of
it
it like in a
does-
lot.
She's thinking of it.
No, this is triangle.
Oh.
Triangles. Yeah. Okay.
It's not an angle.
Yeah. It's okay. It's okay, Tina. I'm glad we got that figured out. Thank you. Now, angle DEG. Shh, gentlemen. Angle DEG. What's my missing angle there, Caitlin? Yeah. This one right there. What's that missing angle?
Geez, 58.
Was
I
it
do my math wrong.
58 degrees? Very good. So that means that is a what type of triangle, Caitlin? How'd you find that as 58?
I added the 68, 54, and subtracted it from 90.
Oh, see, the whole triangle is 1? That'd work. You can also remember that this is 90 degrees. So 90 minus 32 would give us 58 as well. Does that make sense? Either one. Last one, angle or triangle EFG. Well, I only have 2 angles there. What's my missing angle, actually? Max, what's the missing angle there?
E.
Yeah, what's E? What is...
I
what?
don't know. I have the answer. It's like 112.
It's 112. How do we get that? Because that is a line, gentlemen. Because that is a line. So 180 minus 68 gets me 112. And that means my triangle is what, Nick?
Obtuse.
Obtuse. Nice job.
The beast.
Good work there. Moving along here. Now we're going to classify the triangles by the sides. So again, for the sides, we have either an equilateral, an isosceles, or a scalene triangle. Okay, equilateral, everything is equal. Isosceles has 2 congruent sides, and scalene, everything is different. Okay, and again, recognize, what do these little tick marks right here mean, Tom? Those tick marks mean what? They're congruent. So if I need to find a side length, well, what do? I put the congruent sides equal to each other. So 4x equals 3x plus 5. I can get the x equals 5. I plug that back in. All of them have a side length of 20 units. Okay? So I can find side lengths using all that information. Let's try these next 4, classifying them.
Equilateral is a really hard word to spell.
That's a good, what does it say? Spelling word for English.
I'm just guessing right now.
Number 8 here. So let's look at the triangle. If I look at number 8, I notice I have some congruency symbols here. So this means there's going to be a what type of triangle, Drew? That is isosceles. Very good. Now notice number 9. There is no marks on number 9. So that means what, Austin? What might number 9 be? Scalene. Very good. Scalene meaning they're all different. So there's no congruency symbols. Well, then they're all different sides. Scalene. Number 10. What do you say about number 10, Anna? That is equilateral. Yeah, they're all the same there. Equilateral. And number 11 would be Gabe. That is scalene again. Nice job. Good work. All right, take a couple minutes here. Try these 3. Now, I realize the triangles maybe look disproportionate. Trust the symbols. The symbols are correct there. All right, number 12. Triangle EGF. So EGF, that triangle right there. Oh, what do you say, Mats? What type of triangle is EGF? I have this side and this side are congruent. Isosceles. Very good, sir. Okay. The next one, triangle DEF. So DEF. What do you say about that one? Okay. That is scalene. And the last one, although it might not look like it, what type of triangle is DFG? What type of triangle is that one actually, Troy? That one is actually isosceles.
Great job.
Okay, and again, those tick marks right there denote that. Did anybody find the perimeter? What was the perimeter?
Wait, I just need, it's the square root of 1,020.
Why? No, what? Perimeter is the distance around.
And then you have to add that to
numbers,
and the square root of that, and then you have to add
What are you?
What'd you get?
and then
Hey, thank you. 67 is the perimeter. Perimeter is the distance around, Tina.
oh, I was gonna find the calculus.
Yeah, I don't know. That would be wrong. 'Cause that's only for right triangles. I don't think it's the right triangles.
That makes sense. Okay, I was just thinking wrong.
You're wasting time together.
All right. Last but not least, we're going to find some side lengths here. Okay? So as I look at number 15, first of all, what type of triangle is number 15, Tyler? That is a what type of triangle? That is equilateral. They're all the same. So what am I going to do with this 5x minus 1 and this 4x plus 1? To solve for x, I need to do what, Troy?
Set 5x minus 1 equal to 4x.
Yeah, set them equal to each other. 5x minus 1 equals 4x plus 1.
You already know the answer.
And then I solve for x. So subtract 4x. X minus 1 equals 1. Add the 1. I get x equals 2. Then what do I have to remember to do with that 2, Drew? Plug it back in. Plug it in there. Plug it in there. And I get all of my side lengths to be a distance of what, Kay?
9.
What?
9.
9. So that is 9. That is 9. And that is 9 as well because this is equilateral triangle. All of them are the same. Take a couple seconds here. Try number 16. Try number 16. What type of triangle is 16? A little review here, Bryce. That is a isosceles.
Keep it on our phone.
So which two parts would you say equal to each other, Bryce? Which two? Thank you. What do you get for x to equal, Trevor? 1. So that means my side lengths are what then, Trevor?
7.
And the other one? 4. 7, 7, 4. Remember to plug that back in and find the missing lengths. Nice job. Here is your assignment.